Testing. Okay, since there is no class, the next door, so I can use microphone. Okay, so bukan sikit. Okay, so we proceed again. So we proceed again. In a control system, the system are represented in a block diagram. So you can see that this is the example azimuth antenna. The azimuth antenna actually can convert into a block diagram. You learn on control one about Mason's rules, block reduction, and so on. Actually, it represents a system, and the system is converted to a block diagram. So you can see that I cannot read it here. So this is represent power amplifier. The power amplifier have their own transfer function, and then motor and load. They also have their own transfer function and so on. So as an engineer, what you did in control one, is it messy or is it okay? You have a block diagram like this. Is it messy? Messy, yeah. So as an engineer, you need to simplify things. So that's why in control one, you convert everything here into a transfer function. Okay, transfer function is very simple form, isn't it? Very simple form. It just you have the zero and poles. Okay. However, in control 2, instead of you convert to a transfer function, you will convert to a state space. So this is the state space equation. X dot equal to ax plus bu, y equal to cx plus du. Okay? Alright. So it means that mathematics. So this course also required mathematics. So perhaps on Thursday we will do some revision on the mathematics, what you need to have in order to solve equation in control 2. So I'll give you exercise. So these things actually in a matrix form. So the exercise will be based on the matrix equation. Okay? Such as robotic DH parameter and so on. So everything in matrix. So actually what you need to do when you have matrix, you need to find the inverse matrix, you need to find the determinant, and then you need to find the multiplication and so on. So that's the thing. So I will discuss about the fundamentals. So this is the thing, the state space. I believe by another 2 or 3 weeks, you are happy to see this. Perhaps today you feel what is this thing? And what A, what X dot, what D, what U, when. So another next 2 weeks or 3 weeks, before the mid-sem, before the test, you will familiar with this one. Okay. However, in this course also, you need to know how to convert from state space to transfer function and transfer to state space. There is a formula actually. Okay, so you will learn this thing too. So why state space? Why state space or control 2 we call as a modern control? Because also called a modern technique is a unified method for modeling, analyzing, and designing a wide range of systems. Because if you have your system in state space, you learn so far is a single input, single output, or single input, multiple output. Okay, in control control 1. How if you have 3 inputs and 3 outputs? Each Laplace or in transfer function is very complicated, very difficult to solve it. However, if your system is state space, although you have 4 inputs, 6 outputs, the mathematics, the form of equation is very simple, very simple. So that's why you learn state space. That's an advantage. And then can be used in a non-linear system. In transfer function, so far you learn about linear system only. Okay. Do you know what is the difference between linear and non-linear? Yeah? Change over the time. Normally, the linear system, this is a linear system. So it means that you have very specific equation. In this case, such as y equal to mx plus c. It's very simple. However, if a non-linear system, this is non-linear system. In this equation, maybe you have cos theta plus sine theta, theta dot, theta double dot, something like that. So you can see that the non-linear system is a very complicated system, isn't it? So if you have this system, if you convert to the transfer function, the equation of transfer function will be very complicated. However, if you have this kind of equation, you convert to state space, the equation will be simple. Okay? And then after that, applicable to temporary resistor, applicable to multi-input, this is number 4. Number 4, I just explained to you right now. If you have 4 inputs and 6 outputs, the state space is the best modeling and easily tackled by the ability of advanced digital computer. Believe me, this is not generated by AI because I designed this slide not during the AI time. Okay? Alright. So this is MIMO. MIMO, multi-input, multi-output. You can see there's so many inputs and then you have multiple outputs. How about SIMO? What is the meaning of SIMO? Single input, multiple output. Okay. How about how many possibilities you can have? 4, right? CISO, single input, single output. You learn in control 1. CMO, single input, multiple output. MISO tak ada. MISO, I think we have MISO. Multiple input, single output. I don't think so. We don't have MISO. We have BIMO. If you have BIMO, do you know BIMO? It's a character in Adventure Time. Do you know Adventure Time? Do you know Adventure Time? You know Adventure Time? Do you know there's a BIMO? Okay. Do you know? There's a BIMO. Okay, so this is a control 2 is a BIMO system. Control 1 is a CISO system. You learn so far. Okay, so conclusion for chapter 1. So in this chapter, the students will learn about the state space structure. What is the state space structure? X dot equal to A x plus B U, y equal to C x plus D U. Okay. And then next you will do the modeling of the dynamic system, which is convert the system to a state space form. So similar in control 1, you will learn two types of the system, which is electrical and mechanical. In control 1, you convert electrical system to transfer function, and also in control 1, you convert mechanical system to transfer function. But in control 2, you will convert these systems to state space form. And then after that, you will learn about signal flow graph of the state equation. And finally, you will simulate. You will do the simulation on the model system using the MATLAB simulator. So this is what you will learn throughout this chapter. So it means that by completing step number 1 until step number 4, you are ready to do or to perform lab 1. So it means that you only can do lab number 1 until you complete these stages. Okay? And then I believe also this thing will be covered during your test. 1, 2, 3, 4. These 4 things will be covered in your test. Because I'm the one who designed the test question. Okay? And although for the other group also, they will use my question. Okay, so the main outcome of this chapter is that you can work independently to simulate a system when you are only given a system such as RLC and the spring mass damper system. So it means that if I give you a RLC circuit or spring mass damper, and then you know what to do until you can simulate the equation in MATLAB, then you are master for this thing. Okay, ada lagi? Yes. Berapa banyak lagi? Okay, so let know what is the state space structure. So x dot here actually refer to dx over dt, because you know that when we were trying to work right during the final exam, dx over dt, the power of 2x over dt square, it takes time. So in order to help you to simplify the equation, so that's why dx over dt also can write as a x dot t. Okay, and this is what we call derivative of the state vector. Okay, and after that, xt refers to state vector, yt is an output vector, ut is an input of control vector, A system matrix, B input matrix, C output matrix, D feed forward matrix. So you can see that this is U is the input, then U is the input, Y is the output, X is the state vector, X dot is the derivative of the state vector. That's all. And then A, B, C, D is a matrix, 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 matrix. So, at the after you finish this course for the first half, given an RLC circuit, you must able to convert this RLC circuit into this equation. So it means that this is x dot, this is A, this is x plus b u. I will explain how to get this on Thursday. Okay, this is just introduction lah. So how you can convert, how you can solve this thing to convert from circuit to state space? You must have this. You must use this table. This table will help you to get the state space of the RLC circuit. And I also will teach you how on Thursday. Today on Thursday. Next. Similar to the spring example, you need to use this table in order to get the state space.
From the example, you can explain.